12th standard. Today we are going to discuss about the non-stoichiometric defects. Earlier in my previous one video, I have shown you the 3D animations of stoichiometric defect in which Frankel, Schottky, interstitial and vacancy defects you have studied. And today we are going to discuss about the non-stoichiometric defects. In non-stoichiometric defects, as we can see that these are the defects which disturb the stoichiometry of the compounds. What do you mean by that? That the ratio of the compounds, ratio of the elements present in the compounds are different as it is present in the formula of the compound. And these defects are basically because of the presence of excess metal ions, we can say, or deficiency of metal ions, and that's why these can be categorized into two categories, that is excess metal or deficiency of metal ions. As you can see here, in the metal excess defects also there is again further division of two categories. One is metal excess defect due to interstitial, and another one is metal excess defect due to the cationic or anionic vacancies. All right, that metal excess defects which occurs due to anionic vacancies, as you can see here in the diagram beta, that at this one place the anion is not present here. All right, यहाँ पर आपका क्या आना चाहिए था, anion, and instead of that here what is available here, electron which is having a negative charge that is present, and such a defect are known as the metal excess defect which occurs due to the anionic vacancies. Means कि anion की जगह पर क्या हो गया है, space occupy या space create हो गया है. ठीक है, this type of a defect is usually exhibited by sodium chloride or potassium chloride. Means we can say the alkali halides that can show such type of a defect. When we apply or when we placed NaCl and atmosphere of sodium vapors, then it usually result in the deposition of sodium atoms on the surface of the crystal, due to which the sodium atom lose its electron to form or to convert it into Na positive, whereas the chloride ions which is present in the crystal that get diffused to the surface of the crystal and combine with the sodium atom to give NaCl, and in such type of a cases this type of a defect arise. All right, this released electron from Na to Na positive, जो released electron होता है, that also diffuse into the crystal, and because of which it occupy anionic site, means the place of chloride, Cl negative, and this anionic sites that occupied by unpaired electrons. ये कौन ले लेता है बेटा, जो anionic site create हुई वो किसने ऑक्यूपाई कर दी, अनपेयर्ड इलेक्ट्रॉन्स ने ऑक्यूपाई कर दी, जो कि नेगेटिव चार्ज जो अनपेयर्ड थे, जो इलेक्ट्रॉन्स पेयरिंग में नहीं थे, और ऐसे साइट को या ऐसी वैकेंसी को हम क्या कहते हैं, एफ सेंटर्स भी कहते हैं. एज यू कैन सी हियर that blue balls are shown by the chloride and the green balls are shown by the sodium. तो NaCl के क्रिस्टल में आपका क्या है, Na positive और Cl negative placed हो रखे हैं. So such type of a crystal, it usually imparts yellow color to the NaCl because of excitation of electrons on absorption of energy from visible light which falls on the crystal. अब हम बोले कि ये visible light कहाँ से आई, तो क्योंकि जब हमने क्रिस्टल को हीट किया था सोडियम वेपर्स के एटमॉस्फेयर में, तो उसने क्या करा, इलेक्ट्रॉन्स दैट एब्जॉर्ब्स एनर्जी and that due to which it imparts a sodium chloride imparts yellow color to the crystal. Whereas in the similar one manner, lithium usually makes lithium chloride crystals pink. कौन सा कलर दे देते हैं? पिंक कलर दे देते हैं. And an excess of potassium chloride means potassium chloride को अगर heat up किया जाता है, then that gives a violet color. So the alkali halide, lithium, sodium, potassium, these are their crystals are imparting color due to presence of unpaired electrons, or we can say due to presence of F centers in it. Fine. So these are what? These are the metal excess defect. Sometimes it may be also possible the previous one defect arises due to the anionic vacancy, whereas there is a one more type of excess defect which arises due to the presence of extra cation at interstitial site, as I have shown you the figure in the previous one or on the first one slide. ठीक है, तो जब हमारा एक्स्ट्रा कैटायन प्रेजेंट होता है कहां पर? इंटरस्टिशियल साइट, मींस ओपन और एम्प्टी स्पेस पे, then that defect which arises, that is due to the extra cation. For example, when we heat zinc oxide strongly, then it converted itself into the Zn2 positive and 1 by 2 O2 molecules and 2 electrons are released on it. So due to which zinc oxide, which is usually white in color at room temperature or at ordinary temperature, loses oxygen and turns into the yellow color after releasing or after release of these two electrons. So which this effect or this excess defect results in excess of zinc in the crystal, whose formula becomes Zn1 plus X molecule, X number of O oxygen. Fine. These Zn2 positive, which is present excess in this crystal after heating it, that move to the interstitial sites. कहाँ चले जाते हैं? Interstitial sites में, and the electrons move to the neighboring interstitial sites. Okay. Another one type of a defect, that is metal deficiency defect. So many solids that possesses less amount of the metal as compared to the stoichiometric proportion. जितना होना चाहिए, जैसा मैंने कहा कि कंपाउंड की रेशो में एलिमेंट्स की प्रोपोर्शन जितनी होनी चाहिए, अगर वो ना होकर के उससे कम या ज्यादा होती है, तो ऐसे डिफेक्ट्स को हम क्रिस्टल में नॉन stoichiometric defect कहते हैं, which arises due to the heating, due to the impurity, due to the cationic excess, due to the anionic excess. So अगर हम बात कर रहे हैं deficiency defect की, so usually all of us we must know that FeO, iron oxide, it is usually found with the composition which is ranging from Fe93 oxygen to Fe 0.960. Fine. So this range varies due to the metal deficiency defect. In this crystal of iron oxide, some ferrocyan Fe2 positive cations जो होते हैं वो क्या हो जाते हैं बेटा? मिसिंग हो जाते हैं, and loss of positive charge that is made up by the presence of required number of Fe3 positive. So that loss is balanced, but with that क्या हो जाता है आपका? stoichiometric proportion जो है वो क्या कर गई? vary कर गई, and such a defects are known as the metal deficiency defect. Okay, जिसमें कि मेटल की प्रोपोर्शन जितनी होनी चाहिए थी कंपाउंड में अकॉर्डिंग टू द स्टोइचियोमेट्री, वो ना होकर के उससे क्या हो गई? कम हो गई. Last one is what is the difference in between stoichiometric and non-stoichiometric defect? So the basic difference in between the stoichiometric and non-stoichiometric defects, the first one is that is stoichiometric defects do not disturb the stoichiometry of a compound. जैसे हमने बात करी थी previous one video में, Frankel defect, Schottky defect, interstitial or vacancy defect, these do not disturb the stoichiometry defect, stoichiometry of a compound, but in non-stoichiometric defects, the in crystal structures that disturbs the stoichiometry of the crystal. क्रिस्टल की स्टोचियोमेट्री क्या होती है, डिस्टर्ब हो जाती है. Stoichiometry defects are of various types like interstitial, Schottky, Frankel, vacancy, whereas the non-stoichiometry defects are of two types usually, that is metal excess defect and metal deficiency defect. So please again go through the NCERT book, read the topic again and do the revision, and whenever you revise the topic again, go through the video. Thank you.